Cool. So we have moment equals force times distance, okay?
Mm-hmm.
Cool. So when you see a question like this, a ladder or a ramp, then it's a moments question and we're using forces and we're using moment equals force times distance. So I'm going to show you how to work through this question.
Okay.
And the good news is, the bad news is it's very hard. The good news is, in terms of the other topics, the good news is that it's very repetitive. So if you get it, it's repeating the same time every year.
Oh, okay.
I'm just going to draw my diagram. So I've got my diagram. My important points are point A, point B, point C, and also the middle. I'll call it M. Is that okay?
Yeah.
Any questions?
No.
Okay. The ramp has a mass of 20 kg, which means the weight of the ramp is
20.
20 g.
Yeah.
Yeah. And it always goes down the middle. That's why I put the point M. Is that okay?
Yes.
Cool. It rests in equilibrium on rough ground. So I'm going to show you what to do with that. But before we do that, I'm just going to show you one more thing. You know when someone is standing on the ground, they have a weight, right?
Yes.
What force goes up from the ground?
R.
Exactly, R. So whenever there's contact, there's a normal contact force. So it's the same in this topic as well. I have a R this way.
Yeah.
We need to call it R at A because there are other R's in the question as well, not the only one.
Put it exactly above weight R and M.
Sorry?
Why don't we put the R at M because it's above weight?
No, R is wherever there's contact. It's not where the weight is, it's where the contact is.
Okay.
So the other contact is at C. So there's going to be a R at C like this. Does that make sense?
Yeah.
So wherever there's contact, there will be an R.
Mm-hmm.
We
Okay.
have reaction at A and reaction at C. And if this ramp was to break and fall and slip, would it slide this way? Or would it slide this way?
Left.
Left. So friction opposes the motion, therefore friction is this way. If the ground is rough, then it will stop the plank from slipping, right?
Yeah.
So this is equal to mu RA. Friction is equal to mu, the coefficient, times R.
Yeah.
Okay. I've done the mass. I've done the rough ground. I've done the reaction at A and the reaction at C. Now, I just want to do one more thing. Every time, if it says this, we should do cos theta and
Oh, this I
sine
remember,
theta.
yeah.
So,
1 second.
this is opposite, this is hypotenuse. So it's going to be 7/25 and 24/25. Okay. Now, the last thing to do is to go around your diagram and label alpha correctly. Okay?
Yeah.
So, look at where they put, theta. Look at where they put theta. They put it over here, right?
1 second.
No, wait, focus. Don't write it yet. You can write it after. Just focus on what I'm doing. So this is the theta. So we're going to put theta here. Yeah?
Yes.
Okay. So, wait, just keep watching. It's really important. So I'm going to put theta here.
And that means that this
Now I'm going to go to, wait, just 1 second. I'm going to go to every force. And I'm going to just do These are theta. Theta, theta, theta. Yeah? Any questions?
Yeah. Wait. Wait 1 second. One down, going down. Isn't it supposed to be like the other one? Because look, if you draw, it'll be theta next to theta, no?
No,
Like it's
so
theta alpha.
no, like think of it. No, look, so you got, if this is theta,
Yeah,
this one is 90.
yeah,
This one is 90 minus theta.
yeah.
This one is 90 minus 90 minus theta. I'll show you again. Theta. Imagine if theta is 50,
Yeah.
then this will be 40. So this will be 50.
Why? Oh, because it's okay, but you know what I was doing? For example, you put the first theta, yeah?
Yep.
Then I was
That's fine, don't worry. The good thing is, like I said, when we do more questions, it's always the same pattern. So every time if I draw my theta there and I draw a line perpendicular to the ramp, so if I refer to the ramp, remember that the ramp is AB, okay?
yeah.
So my dotted line is always perpendicular to the ramp because we need those forces to do the moments. So let's answer part A and then we can carry on. It's a 9-mark question, so we do everything in one go. So the first question says, why is there a reaction at C? Why is it perpendicular to the ramp? We just have to say that the drum is smooth. We don't need to worry too much about this question. Just, I would honestly recommend that you memorize this answer.
Okay.
If they ask you, okay. Okay, let's carry on. Part B is 9 marks. Now listen to the strategy for this question.
Okay.
There's 3 things that we need to do in almost every ladder's question. Number 1 is we can, if it's in equilibrium, resolve the forces up equals the forces down. Okay?
Okay.
The second thing we can do is we can resolve the forces left equals the forces right.
Okay.
And number 3 is we can do the moments anti-clockwise equals the clockwise moments.
Okay.
I'm going to show you how to do each of these things. And this will usually be around point A. Now, this will be harder. This will be easy. This will be quite hard. But we're going to go through them one by one and we'll do more practice. Okay?
Okay.
So, before we carry on, I'll do it in a way that breaks everything down first. So, do you agree that this is 20g cos theta and this one is 20g sine theta?
1 second.
Good. Do you agree that this is RC cos theta and this is RC sine theta?
Yeah.
Good. We don't need this one, but just we don't need this one, okay?
Okay.
Perfect. And if I need anything else, we can work it out. So let's start the question. Let's do vertical forces. Yeah, exactly. So my forces going directly up are RA plus RC cos theta.
Why don't we take RA something?
It's already going straight up.
Oh yeah. Okay.
And
Wait,
going down, I have
I'm
20G.
understand why is RA cos theta.
Sorry?
I'm trying to understand why is RC cos theta.
It's pointing directly up,
Okay. Okay.
not diagonal.
Okay. Is equal to 20. Yeah, okay, I agree.
So now,
Wait, why is it like 24 over 25? Ah, I see, okay, never mind. Okay.
that's fine.
Yeah.
So how many unknowns do we have?
2. RC
Cool.
and RA.
So let's call this equation 1 and we can come back to it. Okay?
Yeah.
My other thing, the harder thing is we have to do moments around A. So I'm going to ask you a question. If A is the pivot,
Yeah.
what's the distance of this from the pivot?
Distance of this from the pivot?
Yeah, like how far is it from the pivot? It's 0 meters away, right?
Yeah.
So the moment is going to be 0, right?
Yeah.
And the moment of this is also going to be 0. Do you agree?
You mean because they're connected with the pivot?
They're already on the pivot, yeah, exactly.
Okay, yeah.
Okay. But there'll be a moment for this one. And there'll be a moment from this one.
Yes.
Okay. So going in the anti-clockwise direction.
I have a question. Why won't there be a moment for the 20G also?
Remember, there is, but it's the yellow one. Because remember, we only use the perpendicular component of the force.
Okay.
So this is part of the 20G. It's the same thing. It's just we don't use the down part. We use the perpendicular part.
Okay, understood.
So now we have 4 meters.
Isn't it 5?
No.
Yeah, it's half. Yeah,
cool.
4.
So we have force times distance. So we have 20G cos theta times 4 is equal to RC times 5.
Okay.
Any questions?
No.
And you get why we didn't do like RC cos, we just did RC. You understand?
Yes, because they have to be perpendicular.
Perfect. Cos theta again is 24 over 25, so I'm just going to solve this. I only have one unknown, which is good. So I have 20 times 24 times 4 divided by 25 divided by 5. RC is equal to 384 over 25G. I just worked it out. So I get RC is equal to 150.528 newtons exactly.
Okay, now we can put it in the first.
Yes, exactly.
Take the delivery, okay.
So now we can just work out RA, because the question is saying give me the forces at A. Okay. So RA is equal to 20G minus 150.528 times 24 over 25. RA is equal to, in my calculator I got 51.49, so 51.5 newtons will be fine. Now, the only hard thing now is it says the resultant force, meaning I need all the forces at A. So we've got this one. We got this one. Where's one more force at A, which is the friction, isn't it?
Yeah. Mu RA.
Yeah, exactly.
So we just multiply by mu.
Exactly. Do we have mu?
And wait, I'm trying to read. No.
No, good. So we can find mu quite easily. Well, not easy if you're doing it for the first time, but it's not too bad. So what we just need to do is we just need to do horizontal forces. So we can do,
Left is equal to right.
yeah, exactly.
We have no. We have just right. Just one right.
We have mu RA going to the right.
Yeah. But no one is going left.
There's one.
Who's going left?
Can you spot it?
Like the down one, but it's going like. Oh.
Yeah?
But it's going up.
RC sine theta is going left.
But it's going up.
No, how?
Because it's pointing up, it's not pointing down. Isn't it like a vertical force?
RC is pointing diagonal.
Oh, okay.
So
But
part of it is going up. This is going up.
Okay, we can zoom out.
And this is going left.
In this case, isn't. Wait 1 second. If we're taking like this, like diagonal, isn't right also 20g cos theta? Because it's also diagonal.
Sorry, say that again.
If we're taking like diagonal, isn't pointing right also 20g cos theta?
No.
Why?
What, from this one?
Yeah.
I already made my right angle triangle. How can I make a right angle triangle going this way? It's not, this one is vertical. There's no horizontal component. It's straight down.
No, the yellow one.
Mm-mm.
Isn't it also like diagonal?
That's not my real force. I already split it. I can't split it again and again and again.
No, but we can't use the yellow line.
No, because the force is this one. I can't split it again. I can't split this again and again, like forever. That's not possible. I can only split my force once. This was my original force.
Okay, we can zoom out and see something. Mm.
1 second. I actually just realized we don't need to work out mu at all for this question. So I'm just gonna delete this part.
Okay.
All we need to do for horizontal is just say friction equals RC sine theta, which is equal to 150.528 times 7 over 25. So I get 42.1 newtons. So my resultant force at A is equal to 42.1 squared plus 51.5 squared.
Wait, I don't understand.
Square rooted. This one, I can just say friction for this question. So we worked out RA together, right?
Oh, what?
We worked out RA together, didn't we? This
Yes,
one.
yes,
Yeah?
yes.
So I just worked out friction. I did left equals right.
Wait, right is F.
And left is RC sine theta.
But you said that we can't use the green lights for the horizontal.
Sorry?
You said that we can't use the
Yeah, basically we can't split them. Yeah, fine. So the answer is 66.5.
Can you put this in the shared document?
Yes, I can.
Because it's an example that I'll look at.